There you go.
All right. So for the sake of the tape, my name is Joe Nuxall. I'm the Director of Platform Technology at Voxeo, and I'm going to try to take the place of Jonathan for a few minutes here and explain Voxeo's architecture and kind of positioning as it relates specifically to proposal for E-Trade. All right, so let's start at the top. This is redundant for most people in the room, but let's just do it for the sake of the tape. What does Voxeo do? To understand what Voxeo does, well, in regular English, Voxeo is solving classical telephony problems using the web, using web application techniques to do telephony stuff. So a very quick primer in how does a web application work. I'm going to apply that to how we solve phone applications with the web. All right. We start with a computer, and this is a PC that is a web browser. It doesn't have to be a PC, but it's a web browser on a box. This PC is connected to a monitor and to a mouse. So the user experience of this PC is basically on this side of the fence. There's a box sitting underneath their desk, but they're looking at a screen and using a mouse and a keyboard, blah, 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 and maybe a light pen, who knows, to control this application. They open their web browser, and the web browser software will go across the internet and talk to another box somewhere on the internet, which is a web server. This is a server. This is an HTTP server that has sitting on it HTML files, a whole bunch of them. That file goes back over the web to the web browser, which is then displayed on your screen. The web browser does all the code of laying out things, putting GIF files where they're supposed to be, etc. And you can use your mouse to navigate and click different hot links in this application, which then tell the web browser to go back over the net, grab the next file, or a file nearby, or a file on yet another server somewhere out in the world to come back and display. This is hyperlinking, this is hypertext transport protocol, just a protocol talked over the internet to grab files, display their contents, position images, and talk to the infinite number of servers that are out there in the world. So this is how a web application works. On the back end of these things aren't typically just static files. There's some dynamic code that runs on these web servers that go and talk to a database or go and talk to a distributed object system or some sort of thing that corporate America and pretty much corporate Earth just spent the last couple of years and spent billions of dollars developing these systems to tie all of their corporate infrastructure together so that they could serve web pages over HTML. This became a really hot thing. You probably heard about the internet boom, and a lot of money was spent tying all these systems together, these database systems, so that these web servers could serve HTML to be displayed on a person's browser. So big investment in the world building this infrastructure. So over on the other side is the telephone network. All these guys sitting working on PBX boxes were kind of ignored while this whole internet boom was going on. And with sort of the advent of cellular phones and accessibility and now WAP phones, people are starting to look at telephones. And a lot of people will say cell phones, but it's really just all telephones and how they can play in this game of the internet sort of booming. The first attempts of these were WAP phones where you have a little cell phone and a couple, like 4 lines of text, which is extremely cumbersome to get around. And then these voice recognition companies started coming around and saying, you know what, you can use your phone the way you normally use your phone, and we will just do voice recognition to translate the thing that's said into some text. So instead of looking at a little screen, you can hear audio. So let's get into this. To build a voice application or an application that is connected to the regular phone network, you have to buy a lot of special hardware, not just web servers. That's all become commoditized and commercialized, and there's millions of versions of them. You have to buy very specific, very expensive hardware. I don't want to go into too much of a sales pitch. Voxeo has done that work for you. This is a picture of the US. Apologize, it's horrible. We've done that work, and we've actually distributed it around the US at 10 different data centers. You can go to our website and see where the different data centers are. They're all connected. And every one of these data centers has 800 number, 900 number, and local numbers all around it. So we actually have local number access and phone lines pulled all over the US, 150 or so cities. You can get the specific data all on the website. And in each one of these POPs, we have a whole bunch of equipment that sort of ties these worlds together. So let's just say this picture, this is Voxeo. You come over here, you take a telephone, just a regular old telephone. You use your voice, use your lips, and a keypad or whatever as your interface points talking to a regular telephone that's connected somewhere into the Voxeo network, which pretty much means anywhere in the US, and eventually anywhere internationally. We'll be doing Japan and Europe and all those sorts of things. Use that regular telephone, which you can call into or receive a call out of the Voxeo network. And the Voxeo network, will be showing you more of the technology here, talks the same way a web browser does, directly to the exact same web servers that these corporations have spent all this time getting their information together in the form of HTML, and they grab XML. It's either voice XML or call XML or XTML or whatever, some sort of markup language that represents a call flow the same way that HTML represents a video layout of information. So this would be something like play this audio file, listen for this digit to be pressed, or listen for this word to be said, etc. And this technology that sits on this platform, which we call it an AGS, it's often referred to as a voice browser in the case of voice XML. We can then basically let the telephone world be controlled by the web server world. So this, you can build a phone application, either a traditional phone application like conferencing, follow me, find me, whatever, and use a web server to drive it, or you can extend a web application, like a E-Trade, and have a notification service built in so it can make a regular phone call and be driven by voice or by DTMF or whatever. So this is the really high-level picture. Let's go down to something more specific. I'm just going to erase a chunk of this. So some other companies, actually I'll highlight one specific company that started life building one of these applications, not a distributed network, but one of these voice applications. They actually built a portal. They're in Silicon Valley. You probably heard of them. It's Tell Me. They designed their architecture to be behind a single 800 number. So they have one POP. It's in one of the Santa Clara Exoduses. They have, you can get a data sheet off their website. They have this totally redundant cluster, just like you would cluster web servers. And then they have direct connection to the fiber ring with all these huge AT&T boxes. I think there's like 6 or so of them. And these are all, direct connects out to the telephone world on a fiber ring. So they released this white paper when they realized they needed to change their business model to more of an infrastructure play. And about 3 days later, they got a fiber cut in their architecture at exactly the wrong place, which shut their entire service down, their own portal and all their customers and all the extension, for about 6 hours. So in the telco world, that's death. That's suicide. That can't happen. That kills your 5 nines of reliability for the next 3 years. This architecture makes perfect sense if you are a single vertical-oriented application, 800 number, a Tell Me voice portal. It does not make sense at all for a distributed system where you have all this rollover fault tolerance and internationally deployed thing that can't go down, and you have different customers and different applications running. This was designed to be a voice portal, not an infrastructure play. And Jonathan and his team built one of these once about 5 years ago and got their fiber cut and had this experience, but it was for a much smaller scale thing. They know that this architecture doesn't work for a large system. So this is funny for Jonathan, etc., to see, because this sort of lesson's already been learned by them. Our company has that advantage, so that our POPs are architected to be totally redundant and live and not die. So I'm just going to grab one of these POPs, expand it out, and show you what's on that POP. Actually, I'm going to steal a bunch of space from my whiteboard. So one of our POPs, which we have 10 of, internally looks like this. And I've got a couple people in the room to help me with stuff because I'm a software guy, but I've seen Jonathan tell this enough that I can hopefully describe it. We have coming in, here's Gary's version. There's a big box with a bunch of hardware. It has a fat pipe that goes out to the telephone world, and then it has a really fat pipe on the other side that goes to the web world, and there's a bunch of secret sauce in here. That's basically what it is, but for those of you that want more information,
Give me the secret sauce.
yeah, here's the secret sauce. We have, and this is sort of the basic architecture that's repeated at each one of the pops. So we have coming in from a telephone system, we have either an OC1, or excuse me, an OC3, or in the case of Atlanta or Super Pop, we have 4 times OC192s. You know, we have massive bandwidth coming into that pop. Those come into a MUX, or a series of MUXes, that then send this out to a series of 5300s. These are Cisco voice over IP gateway routers. Or gateway router is redundant, isn't it? So these are Cisco 5300s. Racks of these, lots and lots of racks of these. And we only have to use this MUX because the Cisco's can only handle PRI lines coming in, which are T1s, which are the equivalent of about 24 concurrent calls. That's 24 people talking on lines all at the same time. Exactly. So we have racks of these depending on how we need to scale them.
Per Cisco 5300?
I think that's per T1.
Per
Cisco
per
PRI, and then each 5300 can handle 4 PRIs.
Right.
Gotcha.
Right. So to reiterate for the camera, if you didn't hear it, each one of these 5300s can take 4 PRIs, so 4 times 24 calls, which is what, 96 concurrent calls in one of these boxes. So depending on how we need to scale a pop, we can add more 5300s, to handle more bandwidth coming in through the telco side. So coming out of these is voice over IP. This translates all the real-time protocol 50-byte packets into much larger HTTP packets of voice over IP. There's lots of different control protocols. We're currently using H323 for ours, which is a flavor of the call control protocol of voice over IP. And we have this voice over IP network that's roughly 1 foot long. It's a cable that comes out of the 5300 boxes and goes into what we call our AGS boxes. AGS stands for Application Gateway Server. So, and she actually pointed out some things here. We also have, switching equipment, etc. in here. So, one 5300 comes out into a switch, and that goes into hundreds of AGSs, etc. So, and we have a whole mess of AGSs depending on how we need to scale things. An AGS, Application Gateway Server, is a standard appliance. This is a Dell Dual 800 with a gig of RAM, 37 meg hard drive, just massive beasts. They actually have installed in different boot sectors. They have either a call XML implementation of an AGS or a voice XML, the Nuance platform, or they're a media conversion proxy, which we'll talk about in a minute. These are appliances we put in the POP, and in a few minutes, or actually probably a couple seconds, we can change the role of any one of these boxes depending on how we need the load to change. And that can all be managed from our network operations center. So the AGSs then have a voice over IP connection on one side. The other side they have a regular IP connection, just a Cat5 cable that goes out to a switch and goes out to the internet. And we have pretty fat bandwidth into all of our Exodus pops. So what now happens here is a phone call comes in, one of our numbers that we provision, 800, 900 number, or a 408, or a 831, whatever it is, comes in and is terminated eventually at one of these AGSs. AGS will then talk to what we call web core. I'm going to draw web core as a cloud because it's really this distributed database system that is sort of the back end of our provisioning system and our logging system and all that stuff. A call will come into an AGS when a call is received. This we call inbound, and it will talk to web core and find out where this call is supposed to be mapped to. What is, the key is the inbound dial ID, and the value that we return out of web core is what is the URL of the root node of this application. What's the index.html file for this website. So we then return that value, just the name of the website, and this goes out over the IP network and grabs that XML file from a web server out on the other side of the world. There's billions of these, of course. That XML file then describes the call flow of that application. Play this audio file, listen for this word, listen for this grammar. Go ahead.
So the question is, if you have a local phone number that's mapped to an application, and for whatever reason this data center is down, you can obviously replicate the web core database in the other data centers,
Right.
but they're not going to, how are you going to answer that 415 phone call?
Right, how do you terminate that call? Okay, so the question, to reiterate for the camera, is what if, say, our Santa Clara POP went down? So, couple things. First of all, that's 1/10 of our network, which is, that's the party line is, if any one of these POPs fails, it's only 1/10 of our network and we're fine and we're up and running. The real answer to that is, so the Santa Clara goes down, so 408's gone, 415 is gone, all the terminations of those local numbers are gone. So we are working on, this is a future thing, setting, using SS7 call routing. We don't have SS7 yet, we will, we're working on that. Where we can, at that point, terminate, we'll have a SS7 box here somewhere, but we can detect that this service is down and reroute the call through the SS7 network to another POP to handle it. Now, RJ, you want to chime in here?
There's a few other areas where that's going to expand. First of all, in any 800 numbers, that can actually end up being routed in the network-wide to be able to fail over to another POP
Right.
today.
Yeah,
That's
800 numbers
specific
is
to
easy.
800, right?
Yeah.
That
And
any
800.
any of the toll-free or even in a 900 service, either of that can be controlled up at the cloud.
Right.
For local numbers, similar thing, we'll be working with our telco providers, we're working with our partners to be able to redirect that to another POP, be able to have that backhauled to an emergency POP.
Okay.
That's right. Actually, so some of that is possible today, but it's currently based on the reaction time of the telcos that we're dealing with at that POP.
Okay.
So we can do it. It's not impossible. It's not an automated immediate thing that we will be able to do when we have all of SS7 enabled.
So bottom line is, if they're really concerned about it, they can get 800 numbers.
We can, and
Right.
even if in the situation of have a very critical customer, we could work with them on that to make sure that that could be addressed.
Okay.
A lot of the major applications where it's really critical is especially if you have the 800 number, because that's usually a larger scale application
Right.
where you only have a single number into it in a single, no matter where you're calling in from.
And then the web port database, is that being replicated?
That is fully replicated between our multiple super POPs that will actually have multiple massive database servers running that will make sure the data is always up to date.
Right. We can talk.
Real-time replication.
We can talk a bit more about this. The web core itself is this, it's a distributed system,
Yeah.
where it's basically using XML or HTTP to shuffle this information back and forth for logging, etc.
Okay.
It's drawn as a cloud because there's lots of pieces. The provisioning database piece, specifically, we have an in-house database god
Mhm.
who has set up a redundant, distributed database system that allows us to, have a master database where everything lives, which is also replicated.
Is this
But
like Veritas or something along those
I don't,
lines?
you have to ask him all the details on that, and I will, I should and will learn all that stuff.
Okay.
But he has it so, if a particular set of numbers that need to go to a particular POP can be pushed, and the database at that POP will have all those local numbers, and it's live. When an edit is made to the main database, the provisioning database, it'll push out to the POPs that it needs to do the different things. So we have an architect that's a database badass that's doing this kind of stuff. And he actually had it set up so he had four of the AGS boxes doing like 200 concurrent provisions each or something like that, and there was no CPU used on the database box because he does all the optimized stored procedures stuff. I don't even speak his language. Actually, I do, but that's a secret. All right. So let's go into specifics of some of this stuff. An AGS box, which we draw very simply here, has quite a lot of different pieces to it. Thinking of other stuff. You know what? Hang on. Before I even go there, before we even get out to the outside world, we have a huge caching server. This is a dedicated hardware caching solution, which is also a redundant thing. So any request that goes out based on the HTTP cache headers and on the caching tags and the tag that triggered the request of that, they can be cached locally. So the first time you have a huge audio file that you grab, you'll have to wait for it to stream out. After that, if it was cached, it's immediate. It's on a 1-foot cable away to the box that needs it. And this cache is totally controllable by the applications running out here. We also have another thing that sits on this wire. We call the media conversion proxy, which is a sort of a media server or an audio server in most of the cases it's used for, which will take a request by one of these applications that's running on an AGS for, say, an MP3 file. Play this MP3 file. So this world over here doesn't know MP3, it knows EULA, it knows just raw data formats that work on the telco system. So we can go send this request through a caching proxy. If it doesn't have it, it goes through the media conversion proxy, which is another HTTP proxy, which actually has all these codecs that can plug into it to translate media from one type to another type. So it'll go grab the actual MP3 from their web server, just like they have their GIF files next to their HTML, they have their MP3s and their waves out here, and we will convert it on the fly using a codec, an MP3 to EULA codec that we plug into this thing, and it will live while it's, while streaming, we'll be converting that file. We have some really good DSP engineers.
Is there a reason to do that other than development? Because it seems like you would lose the quality, when you're relying on this algorithm to convert the audio.
So the question was, is that only for development because you might lose a lot of quality? That depends on the quality of your DSP engineers. We happen to have some of the best DSP engineers in the world, and these are guys from, I won't go into all those details. Basically, he has done, the main guy working on the algorithms here,
Right.
has done a 300 times real-time to 1,000 times real-time conversion proxy that he actually uses the Fourier transform, so he doesn't lose anything. I mean, the translation is...
Well, like say you're taking a 44 kilohertz file and you're sampling it down to 8.
Right.
Without using SoundForge or something, you don't have control. You're kind of using this cookbook.
This is the kind of guy that would write SoundForge.
Okay.
So he actually has written since, multiple channel slints, and he actually can...
But with SoundForge, I might use multiple scripts depending on the audio file, where this is, you're going to get one...
Right, one algorithm
sample.
to do the thing.
Yeah.
I believe the codec stuff can change which codec is actually working based on a waveform. I don't know that any of that's in there, but...
So the original
I know,
question
something
is
overly
there a
defensive
reason
of
to do it other than just development? Like if you're...
Well, no, this is sort of the merging of the web world and the phone world. I mean,
Okay.
the web people, web applications aren't used to just saving 8-bit EULAs, and that might be a pain in the butt. It might be a different audio format than what they're serving to their website, which can handle different types of formats.
Okay.
So it only does the translation down to what is currently the crappy phone network bandwidth, which will eventually be a much better bandwidth. That sort of stuff's coming down the line, and we'll be able to plug in codecs to do those too. So, I mean, your concern is valid, though the bandwidth that the phone allows really sucks.
Okay.
And we haven't seen in any of the banging on that we've done right now, or so far, that it's caused any degradation other than the fact that it's over a phone line, which is bad already. All right, so that proxy using a codec that basically sniffs the header and sniffs some of the data in the file, converts the file, and then that file is cached as opposed to the original MP3. And then it's played over the AGS, over the system, et cetera, et cetera. So we should jump a little bit into one of these AGSs. You got all this? Everybody? Did you write it all down? Good.
Detail will forever hold your peace.
There's a test on this later.
Yeah. I didn't hear anybody speak up, so...
I'm
All right.
assuming everyone got it.
Here's RJ.
Yeah, this is a
Say hi.
I'm RJ Auburn. I'm Senior Technology Architect for Voxeo. I've currently been doing a lot of voice XML implementation and research, pretty much architecting the Voxeo's voice XML solution.
Right. RJ did all the evaluations of all the different platforms we were able to get our hands on, and has chosen Nuance and continues to evaluate more as they come out, and maybe we'll deploy more than one. Who knows?
You never know. No comment yet.
Right.
Okay, back to class.
Okay, so in an AGS box, I don't think how we should describe this. There's the call XML AGS that we have developed in-house mainly because call XML didn't exist. And there was certainly no vendors that had built an AGS that ran call XML, though we have a parser that we've open sourced and we're open sourcing part of the runtime. And we have a couple companies that have approached us and want to build call XML stuff. And I know I can talk, it's actually too dangerous to put on video, but there's other companies we're talking to that want to integrate call XML into heavy switching equipment. And you probably know who that is already, but I'm not going to repeat it because I don't know who will see this video. All right. So in a particular AGS box, we have a couple layers. There, of course, is the web layer, the HTTP layer to go talk to the outside world over HTTP. There is on the other side, there's a CT layer, computer telephony, which allows us, it's an abstraction, CT abstraction. CT is a term that means computer telephony. This is all the low-level APIs you use to tell telephone hardware to do stuff. Initiate a call, close a call, event systems for detecting DTMF and
that may or may not be
pushing-
telephone hardware. That may actually end up being a voice over IP connection.
Right. Could be anything.
A media connection.
Okay.
So we have drivers that we plug into the system. Like we had, for a long time, we had a Dialogic card driver that we would plug in. We now have an H323 connection that we plug in. Eventually we'll have a SIP connection that we plug in. And who knows, I'll put one right here, maybe an S7 or an SS7. Something like that. Where depending on the protocol or whatever's being used to drive the telephone system, we put in drivers. Currently, this is what we're using.
So back to nuanced terms, is that like the audio provider? Is that
That would be an equivalent of an audio provider.
Okay, great.
Right. So that goes through our CT abstraction, and then this is we have actually white papers and things you guys can grab if you want to. Though I doubt E-Trade is going to want to go that deep. And actually, I won't even go that deep. We have, here you go, there's a parser, which parses the incoming XML, and then we have a runtime, which we actually call CallAsm, which we are putting in for patent. We'll be having a patent on soon. This is actually a bytecode runtime that runs telephony markup languages. And another function of that MCP will eventually be to take any kind of markup and convert the markup to a binary form of CallAsm. So our AGSs will just be running this low-level assembly. That's all future stuff. Okay, so that's what it looks like for call XML. I'm going to call on RJ to describe the Nuance platform a little better because he was probably paying more attention when we went there and they told us. Go ahead.
Let's go ahead and kind of go over the basic architecture of how the Nuance runtimes works. Start off, pretty much there's several different components of how you work with a Nuance voice XML runtime. Let's kind of start off with we list those AGSs right there, and that there's basically a pool of them. Within the Nuance set of pool, there's actually going to be a couple different types of boxes that you're going to work with. Let's start with the first one, which is going to be the box which is actually going to answer the telephone call. We're going to call this a telephony host. This is the box that actually does all the HTTP fetches, terminates the voice over IP call, really does a lot of the media streaming back and forth. So we've got, once again, a layer here where we can have different audio providers. In this case, the one we're using right now with Nuance is the H.323. Similar ones, there's a bunch of traditional telephony cards such as Dialogic and MS, many of those, and as they're moving towards SIP. So those will all be at the audio provider layer. Kind of sitting above that, you actually have Nuance's voice rec client. This is the piece that actually is responsible for streaming the audio to the different places, making sure that passing the data back to the voice recognition server, taking the audio input from the telephone and inpointing it so that it actually can send that off to a voice recognition process to be handled. Above the rec client is the voice web server. This is the equivalent of the parser in the call XML AGS. This handles pretty much, it is responsible for doing an HTTP fetch for any of the script files, processing that, turning it into the actual rec client API calls, and handling all those pieces of it. It additionally also has a component called a prompt server, which handles streaming of audio files into it. So you will actually, this would actually end up being connecting to the MCP, so as it gets the audio data streamed from the MCP, it would actually stream it back to the telephony provider eventually. Each of these is a completely, handles its telephone calls pretty much fairly independent boxes. There's another couple pieces in here. The next piece that does is the actual recognition server boxes. These are the servers that actually do voice recognition and handle that type of application. So let's go ahead and bring this. We call these the services host. Please don't mind my cruddy board writing.
These are in the same box or these different boxes?
This is actually running on a separate box in our network.
Okay.
However, there is the exact same software load. Is just a matter of running a config script to switch it from telephony to services or to call XML.
Okay.
It's pretty much we've gotten that image down. So if we need more, if we're running into applications that need a lot more voice recognition resources, we just throw an extra box, load the image, and type make service. Done. And that it's joined into the cluster. On this, it actually has the Nuance rec server. And this is actually going to have many of these. You can have, literally, with the Nuance platform, hundreds of these in a cluster, where you actually will have some other components that handle the load balancing within the rec client that make sure they register with each other, figure out what is the correct, who's got the correct load, who's got the correct versions of everything. So that each of these can be taken out of service, upgraded individually without any service impacting. Similar type situation with these. You quiesce the calls out of this, have it take no more calls. Meanwhile, you've got 50 other boxes handling the current call load. Any of these items can be taken out of service with zero impact. That is basically the overall architecture. Anything in our network can be to the power of n. Any questions on that?
Can you re-emphasize the modular approach where you can take things out without impacting the operations? Because that's important to the E-Trade situation.
Big item that we did a lot of work with Nuance to figure out how to make the voice web server component so that any particular box or component could be removed. Basically, with the rec server, they're using the Nuance Resource Manager, which actually handles all requests. You can quiesce one of the rec servers to take out of service, to upload a new grammar set of file, a new grammar load, a new software load if you need to upgrade to a new version. That Resource Manager manages taking care to make sure that you have the correct versions there. And once again, similar type thing with voice web server, your process over here, which you're going to actually have 30 or 40 of these boxes, or as many of these boxes as you would need as a POP to handle phone calls. Back here at the 5300, when a VoIP calls comes in, and we've got multiples of these, call comes into here, it is actually going to look at the list of available AGS boxes that can handle voice XML, make a decision based on which has been used, which has the lightest load. It will make an attempt to send that call. If that box is not available or is out of service for any reason, it will immediately route it to the next available box. All of this happens in very sub-second timings, so it's not even noticeable to a user.
Sub-microsecond.
Fair enough. I don't know if I quite get a sub-microsecond.
Okay, but they would start over in a new session, though, right? Does that have all the session variables?
During an actual call, you'll stay within a single. Once a call has been established to a voice Webserver box,
Right.
or through the 5300, that box will handle that call through the duration of that call.
Okay.
Once, you could actually, during a duration of a call, lose a recognition server, and
Okay,
it would be able to reestablish.
Right.
However, at this point of the call fail, this box, concurrent calls on this would be out of service.
okay,
In a standard maintenance window, there's actual multiple processes all connected to it, so any single process could fail and it should be able to keep running. You could then schedule it for a maintenance window. Tell the the audio provider, I don't want to accept any new calls. Same 5300 will not give any more telephone calls. Once all calls are cleared out, then you could do any service you needed.
okay. A couple of things. One, I don't see a text-to-speech engine, is that on?
Text-to-speech is actually also pooled on the rec servers.
Okay,
In our current architecture, Nuance has a generic API for doing load balancing
right.
for all that, so those are all plugged in at those spots also.
And then, the other question I have is, lost my train of thought.
Could you label them as you go if they are AGSs or they are?
All of this is in the common AGS build.
Okay.
So this would, from a technology standpoint and what we deploy to the field, they're all the exact same box. Bunch of Dell 2450, dual 866, 1 gigahertz, or 1 gigabyte of memory, and pretty much all it is a software reconfiguration to add or remove it from the cluster.
Do you only support dynamic grammars at this point?
At this point, that has been our primary item, is doing dynamic grammars.
Okay.
We do, with that, we've actually, there's actually one other component in here, which is similar with our web core stuff, actually an Oracle caching system for the dynamic grammars which Nuance uses. So once that grammar has been compiled, it will actually be cached in the Oracle database server. And once again, that's in a cluster situation also.
Okay.
Any other questions?
But I have a stupid one, which is then, how do we deal with static grammars?
How do we deal with static grammars? This is one that we're working with. There's a couple. At this point, from the way the APIs are with Nuance, everything is, the interface in voice XML is using the GSL grammars. You can actually load basically a precompiled grammar on that and reference that object instead of a GSL file. At this point, you can only do that in the current release in a speech object. However, in the new release, which we're working with them on, that's fully accessible within this voice XML. It's one of those things, unfortunately, that you run into challenges with in the voice XML spec, because they really don't have any coverage for that type of stuff, of those type of grammars.
And how about speech object support? Are you supporting, like, if I write my own speech object, how am I going to load it and run it?
At this point, this is where we get into some areas where we're still working on it right now. At this point, on the boxes, we have the full Nuance Foundation speech object support. And the Nuance voice browser does actually support loading of remote speech objects via use of their object tagging. We're still working with, we've actually disabled that for now and working on some security issues with that.
Okay.
But doable.
Yes.
I mean, that's obviously a big difference between.
For E-Trade?
Yeah. Well, I mean, it's a huge difference between Proxy platform and my understanding is sort of Tell Me.
Yes,
platform.
Tell Me has absolutely no speech object.
There's no way they can do NBest. That's
Correct.
Yeah.
And we have all that in there. Whether we make that publicly accessible to any developer is a decision which is still being hashed out, but in a trusted developer, trusted project, that's no problem. It's just whether we open up that source tag for where you load the class file from on a community developer site is another question.
So just if I sort of take it down to an E-Trade level, what would a speech object help them with initially that they would not be able to do just with straight kind of voice XML?
If there's any sort of NBest choices.
That's type of stuff.
Right, so,
Big item speech objects do is they allow for much more complex applications.
Okay.
There's a lot of pre-built objects
Yeah.
that Nuance has spent a lot of time developing. It's,
Okay.
at this point, is a standard of how to implement that. However, Nuance is the only company that's actually implemented the speech object APIs. So it's sort of in the, they are looking to move that to other
Okay.
voice recognition services also. It actually is a very nice object-oriented way of writing applications, get up to going fairly quickly.
Okay.
It serves a different type of purpose than voice XML.
So I could do something like check the balance in my portfolio. Would be something that you could, for example, say using sort of with speech object versus
you could certainly do that with voice XML.
Correct.
the other voice
That's
XML.
implementation.
Okay. Okay, that's not one
Yeah, both of those can be done. It's just the speech objects framework does allow you to start dealing with a lot more low-level stuff. Voice XML hides a lot of the low-level work.
Okay.
Is there any facility for doing tuning and recording and?
Pretty much all our telephony servers do save all the utterances to disk, which are archived based upon what the commit level with the customer would be.
Just the utterances or the audio that's played as well?
We're working on that actual piece.
Okay.
At this point, it does not actually save outgoing audio, though we are working on that to actually be able to enable whole call recording. That's actually going to be something coming very soon. It's just the current audio provider doesn't support that.
We should point out, this is something we talked about a little bit earlier, where, a customer like E-Trade, we are a customer-focused company, if in your proposal you guys feel that is a strong selling point, then sell it as done. And we will do it.
Yeah.
Yeah, one thing I know that Tummy has is their whole transcription services, Transcribe Me and.
Okay.
What
That's
Webserver
one
has
thing
in
that they advertise.
Yeah, just like.
So that's, one thing, I'm thinking from, tell me, what are they going to be hitting on?
Yeah.
That can be managed.
Okay.
Yeah, the technology, it has not actually been implemented on it yet, but it's very, very simple to implement.
Is that similar to the tool like on vVocal that allows you to hear back the call during the
Correct.
development? Is that separate or?
Similar
Kind of,
type.
Yeah.
Okay, similar type of thing.
Yeah.
then.
Yeah. Though you could send the logs to Nuance for transcription
Correct.
today. That's something
That is built, we've got all that bits enabled right away, but yeah, the whole call recording is very much, we're in the process of working out those
Okay.
final details.
And actually, I don't know if Tommy records the whole call, so,
James there.
yeah, I don't know.
Just tell them we will. Because we can. I mean, cannot emphasize as much. I mean, we customers like this, potential customers like this are really going to dictate the functionality that our network's going to have. And if we can close a deal because of a point like this, then we bet your ass that wants to be in a network. Let's make it happen.
We missed you, but you get a rain check on the engineering meeting.
Sorry.
That's all right.
That did.
Sorry, too.
Was she beating on you or you?
Sure. You're supposed to be there?
Me, but then the meeting was supposed to be on 2 o'clock.
Oh, gotcha.
Then
Crazy day.
yeah.
Yeah, I apologize.
It's all Milo's fault.
Yes.
Blame it on It's those
Yay!
guys in San Francisco. It's their fault.
Yeah.
We're always,
Do
exactly.
you have bullet points you need?
Yeah, let me get into some very specific kind of questions that have come up that I've heard. It doesn't have to be on me. I mean, I think RJ is perfect to kind of keep it
You
up.
gonna continue recording this?
Does this need, do we need to get?
I don't think we need to necessarily record. this
Okay,
whole
we'll
thing.
we'll stop this
Bye
at this
now.
point.
Yeah.
Bye-bye.